ratio at rest is about 0.8. It varies a little bit, 0.8, 0.85, but let's take 0.8 as a ballpark value. So you can see that if we divide 40 by 0.8, we get 50 millimeters of mercury, and therefore this says that the alveolar PO2 is equal to 150 minus 50, and that's 100 millimeters of mercury. So that's a nice way of seeing that the normal PCO2 is 40 and the normal PO2 is 100 millimeters of mercury. Now, what happens to the PO2 in hypoventilation? Well, let's look at the next image here. Here we've got the hypoventilation situation. Again, the alveolar gas equation. Alveolar PO2 is equal to the inspired PO2 minus the alveolar PCO2 over the respiratory exchange ratio. Let's neglect the R value there. And so if we have hypoventilation, let's assume that the ventilation falls to half of its normal value, the alveolar ventilation is halved, then the PCO2 will double from 40 to 80. So the equation now is that the alveolar PO2 is 150, which is the inspired value, minus 80 over 0.8. 80 over 0.8 is 100, so the alveolar PO2 is 50. So what that means is that during hypoventilation, if you halve the alveolar ventilation, the PCO2 doubles from 40 to 80, the PO2 goes from 100 to 50. You'll notice that the PO2 falls a little bit further than the PCO2 rises, and that's because the respiratory exchange ratio is 0.8. If the R value was 1, the fall in PO2 would be exactly the same as the rise in PCO2. Now, here's an interesting little problem that we're going to solve using our alveolar gas equation. And the problem is this. Suppose we have a patient with a reduced alveolar ventilation. The alveolar ventilation is halved, and therefore the PCO2 is 80. The PO2 is 50, as shown here, but we'd like to restore the PO2 to the normal value of 100 by giving an enriched oxygen mixture to breathe. The question is, what concentration of oxygen do we have to give? Nice little problem. So let's look at how we can solve that. What inspired oxygen concentration is required to return the alveolar PO2 to normal when we've halved the alveolar ventilation? Well, again, we've got the alveolar gas equation here, and what we want is a PO2 of 100. In other words, what we're asking is, how do we return the alveolar PO2 from 50 to 100? So the inspired PO2 now is not known. That's going to be changed by giving the enriched oxygen mixture, but the PCO2 is 80 over 0.8. And so if we solve this equation, you can see that this thing here is going to be 100. So the inspired PO2 is going to be 100 plus 100, or 200. So in other words, the answer is, on the way to the answer, we've calculated that the inspired PO2 has to be 200 millimeters of mercury. How do we get an inspired PO2 of 200? Well, we use the equation that we've already talked about, that the PO2 is the fractional concentration times 713, because remember, we're dealing with moist inspired gas, so we have to subtract the 47 from the 760 millimeters of mercury, giving us 713. So now we simply solve that equation. FiO2 is PiO2 over 713, which comes out to 0.28. So the answer to the question is, if we give an inspired oxygen concentration of 28% instead of 21%, we can return the alveolar PO2 to the normal value of 100 in spite of the ventilation being reduced to half of its normal value. Now that's a very interesting finding, isn't it? Because what it means, it's very easy to increase the inspired oxygen concentration by 28%. I mean, normally it's 21. All we're doing is raising the oxygen concentration by 7%. It's dead easy to do using cannulas in the nose or a mask or something like that. Very easy to do that. So what this means is that it's very easy in practice to overcome the hypoxemia caused by hypoventilation by giving the patient some oxygen to breathe. Very easy to return the PO2, the alveolar PO2, and therefore the arterial PO2, to the normal value in a patient who is hypoventilating by giving oxygen. Relatively easy thing to do. Okay, now let's move on and look at the causes of hypoventilation. Now, I'm not going to go into this in detail because this really is, I would if I was giving a lecture in clinical medicine, but I'm not. But let's look at how we would classify the causes of hypoventilation. If someone asks you, well, what are the causes of hypoventilation? This is the thought processes that I would go through. First of all, you could have mischief in the respiratory centers. Now, we haven't dealt with those yet. We will when we come to the control of ventilation. But ventilation is controlled by centers in the brain stem. And so we could have inflammation of the brain, encephalitis, for example, or we could have the action of drugs such as morphine, and they would reduce the level of ventilation. So that would be a cause of hypoventilation. Another cause would be interference with the nerve tracts coming down through the spinal cord. For example, dislocation in the neck and compression of the spinal cord. That would cause hypoventilation because that would remove the impulses going to the nervous impulses controlling the muscles of ventilation, which we'll talk about in a later session here. Then, since the nerves come from the spinal cord through the anterior horn cell, that's where the connection is made, we could have some sort of disease there, such as poliomyelitis. That affects the anterior horn cells. Or we could have a disease of the nerves themselves, some kind of neuritis, all sorts of neuritis,